we've been looking at properties of functions, and in this video, there's one or two more things we want to look at. First off, we want to do operations on functions. And essentially the idea is, once you define a function f of x, suppose you define another function g of x. Then logically, this is math, you want to know, can I do the function f plus g of x? Can I add functions together? We're not going to spend a lot of time on these. These properties are pretty straightforward because, well, all things being equal, they're pretty obvious. If you want to find f plus g of x, you do f of x plus g of x by definition. So if I want to add the functions f of x equals x squared and g of x equals 2x plus 1, then the sum f plus g of x is just f of x plus g of x, and I can substitute in x squared plus 2x plus 1. So I'm not really changing anything or doing any really complex math. And by extension, I can do the difference, f minus g of x. But logically, if the sum of functions I add them, for the difference of functions, I subtract them. After addition and subtraction, we have multiplication. I can do f times g of x, which will logically be f of x g of x. And then I can do division. F over g of x is equal to f of x over g of x. Really quickly, just to see these worked out, there are one or two important things. Suppose I have the function f of x equals x plus 1, g of x equals x minus 1. Then, if I want to do f plus g of x, I add them together. So I get f of x, x plus 1, plus g of x, x minus 1. Which gives me x plus x, 2x, 1 minus 1, 0, and there's my sum. If I want to find f minus g of x, I do f of x, x plus 1, minus g of x, which is x minus 1. Make sure you distribute your negative in. X minus x is 0. 1 minus minus 1 is 1 plus 1, which is 2. I'm going to quickly run out of room here, but if I want to do f times g of x, that's the product, so I multiply them. X plus 1 times x minus 1, which you guys recognize as a difference of squares, x squared minus 1. You can just FOIL it out if you're unsure. The last one, f divided by g of x, is just x plus 1 over x minus 1. And there's nothing I can do from there, so I stop. But if we recall when we defined functions, once we defined functions, there was maybe one thing in particular that we cared about, the domain of our functions. And as it turns out, if you look here, the domain for here, for f, is all real numbers. The domain for g is all real numbers. When I do the sum, 2 of x, I get all real numbers. When I do the difference, I get all real numbers. When I do the product, I get all real numbers. Essentially, whatever the domains are for the two functions you start with, that will be the domain of the sum, the difference, and the product. If the domain of f didn't include 5, then you wouldn't include 5 for any of these. The domain carries through the problem. There is one caveat though. For the quotient, the domain of f of x is R, the domain of g of x is R. The domain of f over g of x isn't R. Because in this case, once I include division, I include some x's, in this case x equals 1, that will make this thing undefined. Which means, when I do this, my domain changes. When you divide functions, you have to account for the fact that the denominator can be 0, so your domain will be different. So just keep that in mind as you work through these. I don't want to spend a lot of time working through this because it's pretty obvious. There is another fun thing we can do though. There is what is called composition of functions. we compose two functions together, or we find their composition. The way we actually write it in math is f circle g of x. The idea is, I have a set here, call it x. I have another set here, call it y. Maybe I have another set here, call it z. And when I do f circle g of x, that is the same as f of g of x. And then I take some point, say right here, call it x, in this set x. I start on the inside, I apply g to it, so g will take my x and send it to y. Then, once I get the point here in y, I apply f to that, and I go over here to z, and I get a point here. So essentially, I'm doing two functions, one after the other. I start with a point here, I do one function to get here, and another function to get here. I could write the functions one after another. The composition is just a shorthand math way of writing it and doing it. So, to see this in practice, suppose I have f of x equals x squared plus 1, g of x equals 2x minus 1. If I want to find f circle g of x, I use the definition. That is f of g of x. Now I substitute. F of g of x is 2x minus 1. So I replace g of x with what g of x is. Now I apply f to that. We've done evaluation of functions before. What does f do? It takes whatever you plug in my case 2x minus 1, squares it, and then adds 1 to it. And there we go. So again, if you remember our evaluation of functions, this is something squared plus 1, something squared plus 1. I just replace the something with whatever I have up here. So, just to make sure we kind of have an idea of what's going on, we just did f circle g of x. Now over here, we're going to do g circle f of x. So do the same thing. G circle f of x is g of f of x, which is g of, what's f of x? X squared plus 1. Now, I apply g to that. What does g do? It takes whatever you plug in, x squared plus 1, multiplies it by 2, and then subtracts 1 from it. So there's my 2x minus 1, 2x minus 1, where that's the x I plug in. And again, an important note here, f circle g of x is that. G circle f of x is that. They're not equal at all. So do not assume that f circle g and g circle f are the same. In general, they're not. There are times when they will be the same. We'll look at that later in the semester. But just to make sure we're clear, maybe we'll do one more of these and then be good. So, we'll just use f of x equals 2x squared plus 3. Find f circle f of x. You can compose these however you want. So f circle f of x. By definition, that's f of x, which is f of x, which is 2x squared plus 3. Now I apply f to that. What does f do? It takes whatever you plug in our case 2x squared plus 3, squares it, multiplies it by 2, and adds 3 to it. 2x squared plus 3. 2x squared plus 3. Once you kind of get a hang of this, you can actually mess around with it. I'm not going to do it anymore in this video. But if I had f of x, g of x was equal to x plus 3, I could do f circle g circle f circle g of x. I can compose as many times as I want. The principle is always the same. If I did it here, that would be f of g of f of g of x. Put all my parentheses, 1, 2, 3, 4, 1, 2, 3, 4. And then I would start on the inside. For fun, pause the video. Use this f and this g and see if you can do this. You'd replace g of x with g of x, apply f to it, apply g to that, apply f to that. And again, you just keep on going over and over and over again. We are going to come back to this later in the semester. These are important. For right now, we just need to have a working knowledge of what the composition is and how to find it algebraically.